Without the double checking this time. Okay, so tree diagrams continued. What we ended off with was looking at heads or tails, 1 over 2, 1 over 2. Let's do another one single event and say, okay, we got a differently. So I'm going to write you example 2, video 2. In this event, I'm going to look at the probability of me doing mathematics today. Quite high. Well, it's almost a certainty. In fact, I don't know, is it a certainty that you do maths every day? It's an interesting question of what makes something mathematics, of if you're doing something and their mathematical properties and thinking to it, does it still mean that you're doing the discipline of maths? Just because I'm rolling some dice doesn't mean that I'm doing mathematics. Okay. Anyway, that's a good debate probably to have. So probability of doing maths. Now we are now beloved tree diagrams. So I'm just going to tell you, here we're doing maths, and let's do like that, maths, and the other one is no maths. So either one thing or the other thing must happen. There's no in between. I'm not half doing maths. I'm either doing maths or I'm not doing maths. And I'm going to tell you that the probability of me doing maths is a solid 8 out of 10. And let's pause at our tree diagram there. Now this isn't a simple coin toss where it's 1 over 2, 1 over 2. What's the probability then of me not doing maths today? Well, how do we work that out? You might say already, okay, well, I know the answer. Well, one of these two things must happen. So let's look at it like we did for our previous question and said, what's the probability? In fact, let's do it up here. What's the probability of doing maths or of not doing maths? Well, one thing must happen or the other. So the probability of them both happening is 1, or not both of them, of either of them happening. Either doing maths or not doing maths. Now we know the probability of doing maths is 8 out of 10. We already saw in the previous video that if we're going or, then we're adding because there's another thing that could happen. So probability of doing maths is 8 out of 10. Probability of not doing maths, we don't know. We haven't given it. But we do know that when we add them together, we must get 1. So therefore, this number over here, this mystery fraction, 8 over 10 plus what gives you 1? Well, if we make the denominators the same, then we can just add the numerators. So 8 plus 2 gives us 10 over 10, gives us 1. So therefore, it must be 2 out of 10. So there's maybe a better link to this, oh, notice that they add up to 1. Well, they must add up to 1 because one of these things must happen, maths or not maths. So if we looked at the probability of maths or not maths, it's 8 over 10 plus 2 over 10 must give us 1. One of those two things must happen. Okay, so now what we're going to look into in video 3 is, and this is a short one, but I kind of brought things together, at least in my mind. Every time I do this, something new kind of clicks into place. And what we're going to look at next is what happens if there's another event. So in this case, we're going to extend this and say, what happens if we toss the coin twice? And in this event, we're going to do maths or we're not going to do maths. And tomorrow, we're going to write a test. Well, not really tomorrow, it's next week. But, we're going to write a test and we're going to see what's the probability of one doing well or not doing well. And it's going to change whether you've done maths today or not done maths today. So that's going to depend on the first event. The first one is independent. The second coin toss doesn't matter on what happened on the first coin toss. Okay, so that's that. Let's leave it at that. Bite-sized chunks and into the next one.